my workshop here with you guys is to try to get as much information across about the development of technology and go through all of the innovations that we get to utilize in our society and work with today. It's really about empowering people. The more you know in our knowledge economy, the more you can participate. And so I'm going to try to get across as quickly as possible as much information as possible and show you a couple ways in which you can turn for direction in your life, in your career, in this knowledge economy, as well as being able to get a sense for the lay of the landscape technology-wise and see where you might, test a few ideas of your own to see where you can be very effective and grow into it. So I'm going to do that by starting off with this agenda. Going through the history of technology briefly. I'm going to try to go as fast as I can into like the machine age, where a lot of computing technology originated with mechanical computing, and then go into what really in the mid 20th century ushered in the information age and the age of the computer, and then where we are today with the internet and career hacking. So bear with me as we begin. The history of technology, the history of the use of the word technology originated thousands of years ago with the Greeks, where they were really just sort of advancing the state of civilization with several inventions that were key that we use today. They invented gears, they invented mathematics, they invented democracy. And so the thing is, you can't picture today a bicycle without gears. So they really ushered in a whole progress in technology, and the word technology came out of that growth. And even though once it made it to the English language, technology was more and more meaning, people ascribed it for things that were what we think of technology today, things like machines and things like today, even modern computing. So it really took on a much greater meaning, even though it's more in a refined space. The Greeks applied it to more things. So moving on, though, well, what were the Greeks really doing? There were a lot of computing devices, things that in the dawn of civilization, when we began as human beings, beginning trade and beginning inventory and stuff, they used the abacus to calculate, things in trade and as well as keep track of inventory. But the Greeks ushered in this whole new invention with gears and mathematics that took it to a whole new level. In fact, the Greeks could be credited for inventing what could be called an analog computer. And this would be a mechanical device driven by the gears to come out with a computed result. And that, in a sense, is what modern computers still do today, but they do it in an electromechanical way. But back then, it was far much more had to be driven by gears. And so you can find that they had this analog computer they invented. They found it was dated to 150 years BC. That calculated the position of interplanetary bodies, the stuff you see in the sky. So they were able to predict successfully solar and lunar eclipses with this device. Also, something that really needs to be given a lot of thought for is that how the word computing hadn't really begun to take hold yet, but there were a lot of human computers, people who used computing aids like the slide rule in order to be able to do a lot of the mathematics that came out of Greece. And so the slide rule was incredibly powerful. It was literally just like what you would think of a modern ruler today, but you would be able to slide it, and it had markings on it and allowed you to do very complex calculation with it, including trigonometry. So this is pretty amazing, and this is an invention from the 1600s. So we're talking about this thing was used, this slide rule was used by human computers to do all these advanced mathematics for 350 years, right? And that's a tremendous reign of how long this thing was with us. And for the most part, it was definitely used in business, in industry. However, it was also used, for example, to calculate the trajectory of things like cannonballs and stuff, you know, and so it was widely used for all of these purposes. And it also was used by our more modern society, our you know, advanced society in aeronautics and in finance. There were special versions of it. And this slide rule could be thought of as a computing device that came pre-programmed, and the human person would use this thing to compute a result with these 3 pre-programmed measurements, so you could do these calculations. So there would be there was at least 3 pre-programmed sets of things where you could calculate an algorithmic result from a slide rule. The part that the human needed to do was still place the decimal points, so there was still a really important task by the person to be able to do these calculations, but that's no different than today. With today's computer, it still takes a person at the terminal right now or on the keyboard manipulating a computer in order to help it do its thing. But you know, what we think of as modern computers today really is probably more akin to something like you know, a mechanical device that does computing that you might think of as basically a computer. And this really came about in the machine age. It had a lot of advances, and through the mid-20th century, where it really became defined differently. So it started with all these advances in other scientific areas. A man named Babbage had at his disposal some new kind of power that he was able to control gears to make more advanced calculations from. Unfortunately for him, he had issues with people who didn't have much faith in him, and even though he was in the right place at the right time trying to install his machines into industry to make them more efficient, he was never successfully able to complete his analytical engine that he invented. But theoretically, it was the first machine that could be said to have what they call Turing completeness. And in the next thing you see here, 1936, Turing, the Turing machine. The Turing machine in 36 was a theoretical computer, a universal computer, that Turing, Alan Turing, this is a man and someone you should definitely get to know, probably we're talking about hacking and hacking your careers. Alan Turing is probably the first and the greatest computer hacker ever. He started this whole modern computing era. He pretty much single-handedly defined computer science by laying in a meadow in 1935 and dreaming up what he called the main idea behind his universal machine, which was written about in this 1936 paper, where he described the Turing machine. And later on, his theories were expanded on greatly, and by himself, he expanded them greatly to encompass more things. But the initial seed of an idea came from this 36 paper. And as recently as a year following that paper, he was already tinkering. And again, the word hacker, he's hacking together from spare parts from the telephone industry using electromagnetic switches from old telephone networks to be able to calculate multiplication using electromagnetic switches. And it was basically a Boolean calculator that allowed him to do that. Notably, there were at least 2 other people that at the same year that were doing the same thing, but theirs was limited to addition, where his was multiplying. So, you know, Turing deserves special mention. I could go down a huge rabbit hole with Turing and talk a lot about how much this man meant. And he was also family. Turing was lived in a time, unfortunately, when he lived in a time when homosexuality was outlawed in Britain, and he was prosecuted, which led to his death. So here's a man who contributed greatly, and in no small measure was as effective on our world as someone like Einstein in what he contributed, but most of his work was in secret because he was winning the war for the Allies in World War II, and most of what he contributed was in secret, but only now we get to know about what a great contribution he made to our modern world. And even the visible parts, the Turing machine, the intelligent machinery, and leading to computers that were built around his idea, the idea of a stored computer and something that was reprogrammable. These are things that are his legacy, and we get to live with them today because rooted in this innovation is what we have sitting in our laptops when we're using a laptop computer, or on our desktops when we use a desktop machine. Even in our phones or tablets, at the root of all of these things is this idea that he really came from. And this quote sums up virtually everything. I'm going to squint here a little bit and read it. We are trying to build a machine to do all kinds of different things simply by programming rather than by the addition of extra apparatus. That quote in 1947 by Alan Turing sums up pretty much what he contributed and successfully led to the computers of the 1950s and the 1960s, and still even all the way through the innovations of today, even though we considerably modernized it with further innovation. But the thing is that this basic idea of a universal computer is what we have in our hands now, which give us this power to be able to compute algorithms that define the world as we know it and all of human knowledge, and be able to compute some kind of result out of those things, or feed it in and make calculations that using algorithms that are, the word algorithm is basically like a recipe. You can think of it like that make all these calculations, and the fruits of all of that machinery that was conceived by Turing is what we live with today. So he ushered in, Turing ushered in the information age, really. And this was the dawn of the computer age, the digital era, and so on. These huge manufacturers were the first to benefit from it post-war. Rand, Bell, IBM, these were companies that, and the reason why companies is because the computers of the day, in 1950, an ENIAC, for example, was an 80-foot long computer, 8 feet high, right? So the reason why the slide rule continued to be important is because a slide rule was in your back pocket and you could carry it with you to school or your research lab. You can't grab an ENIAC and put it in your car or the trunk of your car and take it to work. So these computers were gigantic, and it took the investment level of a Rand or an Bell or an IBM to create these machines and install them in businesses that were interested in it. Now, one of the early uses of the ENIAC, which was among the first, one of the first reprogrammable and stored program computers, was the US Census, keeping track of the American US population. And doesn't that sound familiar? So they've been doing it for a very long time. They're not about to stop. But there you have an early computer that was able to do these things. It was able to conduct, at least there were, I think the UNIVAC by Rand was able to do 2,000 mathematical computations every second. And this was early 50s too. I think 51 or 52, the UNIVAC was out. And so these computers at the time were also being pitched to businesses and trying to get into industry, like predicting the weather and all these other things we take for granted today. Back then, the information age was just the dawn of the information age. Come the 60s, though, you had some innovations of networking, which is really where things enabled what we really can think of today is how much we've got with the internet. But still back then, one of the huge final contributions that Alan Turing was able to make relatively late in his life was the question, can machines think? And he came up with what is still called the Turing test. And although it's, you know, quite an interesting test, here it is. If a computer, on the basis of written replies to questions, could not be distinguished from a human respondent, then it must be thinking, okay? So that is an interesting definition, and you have to think about what you, how you might define the word thinking, and whether you could ever ascribe such a word to a computer. But you get to little behind the scenes look into Turing's mind there when he was inventing all this stuff, that he was, what he was on about, which is, I would love it if I could create a machine that could do some thinking. That would be amazing. So anyway, here are some other incredible milestones for you. Each one of these could easily go down a rabbit hole and I could be talking days, but I don't have that much time. So I'm going to just scooch over them a bit. But Grace Hopper's contribution with the compiler allowed the women programmers who were the ENIAC women, which were the women programmers who were programming the ENIAC, allowed them to start thinking in terms of programming using English words instead of punch cards. Because at the time, computers required a feed of punch cards. And these punch cards represented symbols. And the symbols to the machine had meaning, and that would allow it to process those 2,000 mathematical calculations a second. But fast forward to 52, Grace Hopper comes along. She's an admiral in the US Navy, even today, by the way, invented this computer compiler program, which allowed people to use English words instead. And then that led to a further innovation of being able to use a keyboard for direct input into computers in 1956. And then shortly thereafter, programming languages, and all of these were Turing complete program languages. Early ones, an example would be of Fortran, and I can tell you it's still in existence and people still use it in business today. Mathematic, which was Grace Hopper's language. Lisp, which is still used today. Hyperlinks and hypertext was actually invented back then. Now, you might take them for granted today, and in fact, for 20 years after their initial invention, they did sort of fall underground and only to be resurfaced later as on the web. But the information age comes of age in the 60s with this whole idea of networking that I mentioned, because with a machine that was so humongous, it was the size of a whale, you can't put that in your back pocket. You can't put it in the trunk of your car, but companies like IBM and RAND could install them in cities or in large businesses, and users could end up having a terminal on their desk that would log in and share time on a central processing machine, like a mainframe. So that was the business. It would be more about renting time on a central unit rather than having the entire machine yourself in what would later become the personal computer revolution. Because back then, that's what they were dealing with. But again, I want to make sure that the reason I'm bringing this background history forward is that we still operate using that construct. A terminal is still technology that we use today. In fact, I have it sitting on my laptop here. The idea is, or the concept is, what used to take an entire company with a central processing computer and all the workers connected to it via a terminal is now shrunk down into size to the size of your iPhone or your Android phone, because the same power that powers those devices are sitting there in the phone. Now, they're not all exposed to you as a user because the companies, Apple and Google, have layered on top a whole set of windowing technology that hides those facts. But all that power that was vested in those huge mainframes in the 60s has been shrunken to size to fit a handheld device. And largely ushering that era in was Intel with their invention called the microprocessor, which was taking those central processing units and stamping it into silicon, hence the name Silicon Valley. So that's the real innovation of miniaturization, taking all that power and shrinking it down so that you can have in your hand the power of what in the past would have been incomprehensible. So computer networking was still there, even as computers started getting smaller and smaller. And in the '69, the government invented this thing called the ARPANET, which was really a defense against possible nuclear attack by enemies. And so they created this switching network system that was alongside the telephone networking system. And it allowed transmission of data. And they invented a protocol called TCP/IP, Transmission Control Protocol, Internet Protocol, by Vinton Cerf and his team. And that allowed networks of computers that were networked in institutions like research institutes, schools like universities, to be able to set up a network and then actually communicate with other such universities and other such research institutes and be able to communicate over the TCP/IP network, which is the precursor. It's basically the internet. And quite quickly, all the traffic, once this next invention, email, came out, almost all the traffic on the internet was email. And that's because it was the easiest really to interface with. If you're a research scientist, you're probably dealing in chemistry and physics and stuff, and you're not concerned so much with other kinds of network traffic. You just want to send an email to your colleague across the world. But that was where the internet came from, and this is long before the web. So when you hear about people talking about, well, is the internet older than the web? That's what they mean. It's true. And they did have FTP and Telnet as other protocols. And there were some commercial protocols because it was a government-run thing. It was not allowed to be used for commercial purposes. There were commercial networks coming along by Oracle and stuff, that OTP, I think, is the one, where they were trying to invent or co-invent what the internet became, or what the web became, by trying to make it something that would be okay to use commercial stuff. But the personal computer revolution started happening before the internet was open to commercial use. So at least what happened was the Intel and small chips and miniaturization of computers allowed a couple of guys named Steve in Silicon Valley, Steve Wozniak, who was the engineer who would solder together this board, another famous hacker, and Steve Jobs, a marketing hacker, basically. And so you have these two personalities, Steve and Steve, who had as hobbyists and hackers, put together this motherboard in 1976, the Apple I computer. And it sold 200 of these motherboards to enthusiasts and computer hobbyists, because what happened with this personal computer revolution is that these computers, you had to go to the university or you had to go to your research lab to use a computer. But when they got small enough, you could get one from Steve and Steve, and you could hack together with, you have your own monitor and stuff and put it together, and then you have a version of a computer in your house. And so that's the dawn of the personal revolution era. And the thing that was missing from 76 through 91 was the internet, because personal computers were primarily not on the internet until later, when the NSF, the National Science Foundation, which controlled the internet, allowed commercial traffic. When they did that, boom. And at this time, this is when the protocols Gopher and World Wide Web came into being. And so the web as we know it today was born at that time. It was around in around 89, I think, and 90. And the Gopher was much more popular at the time, but it faded away because the university that it came out of wanted to earn money from it, and that pretty much ruined its chances. And it was especially noticed when the web you could put pictures on, and the Gopher network, a Gopher client couldn't render pictures, even though it was possible to. They just didn't have the backing by the university to recode it. So that was what happened to the Gopher. It fell by the wayside, but web took off, and web is what we use today. In fact, we're using it now, of course, along with just the internet and all these TCP/IP protocols. Now, because hackers put together all of this stuff, you know, hackers come in all sorts of flavors and sizes. So we have this issue where some hackers are going to be, you know, thinking of advancing and innovating the state of technology, and others are going to be looking at trying to poke holes in it and figure out how they can kind of, you know, hack their way in. So out of again, starting with Alan Turing in his work, and his secret work during the war was decrypting encryption. And at the time, it was the German army encryption, where all their secrets were going over the airwaves. You could get them with a simple antenna, but the words you would get from the antenna would be gobbledygook. You couldn't read any of it. And what he was able to do to save the world was to decrypt those messages and win the war. Today we have the same fight going on, obviously, and encryption plays a huge role. And in the 90s here, in the PGP, pretty good privacy encryption, was invented. And so therein is the whole world of security. So that's a part of also what you want to pay attention to if you get into it. So right now, I'm going to switch over to thinking about you and what role you might want to play leveraging all this amazing technology that comes from the past, because you have at your disposal all of this power. It's literally at your fingertips, even in your pocket on Android or iPhone device, or one of those tablet machines, and I have them all. It's just all the technology is there. Of course, if you have a laptop or a desktop, you're going to have an advantage. And the thing is that with those, with the greater horsepower, you can have increasing power, but ultimately you don't need to get into expensive hardware to have such a thing. You could buy a relatively inexpensive, you know, TV that has HDMI inputs, and you could buy yourself a Raspberry Pi, which has got a Unix-based operating system on it, and you can get it for $35. So it's truly the power at your disposal for virtually nothing is just amazing today. And so to take advantage of that, really, I imagine that you should think about your role and what you want to play. If you're a creative type person, you don't ever have to get into coding at all. You never have to deal with code. And I want to emphasize that. You could be a terrific graphic designer. You could get into web design and you still don't have to know too much code. Web designers are out there that can do a lot of nifty things with the frameworks that are available that other people have coded. You may be aware of Squarespace and Wix and WordPress is out there that you can really hack to death. And so it's just awesome, the power that you have with not even having to know a lick of code. And you can get into these disciplines and contribute, because I'm telling you, people who know how to code are looking for talent like that. So if you want to dip your toes in, go for it. You may find that some of the tools and things may get into a little bit of expense there. If you don't want to dip your toes into code, you may have to buy Photoshop or something. If you want to tick it up a notch, there's other competing image processing software you could purchase also, but it's usually purchased stuff. There are open source equivalents, so you don't have to pay, but you know, it's just when you get into that world, you might be looking at stuff that might be a little bit more. Now, when you're a full-on nerd and you're like, no way, man, show me the code. I want to know what's going on under the hood, right? Then you're going to want to be able to, you're going to need to be okay looking at source code. And on your computer, you're going to want to burrow underneath the windowing software that's on top, whether it's Windows or Mac OS. You're going to want to go down into what they call a command line prompt. And some of the careers you could get into would include things like database administrators. There's people looking for database administrators. There's system administrators, which is fully awesome. That's when you handle your own OS and configure it, and you handle security and stuff. And DevOps. DevOps is short for development or developer operations. And that's where you get into containerization of containerization of machines that run applications, and you can scale. And this is when you would become useful to startups, that if they get wildly successful, it's the DevOps people that allow you to scale up without crashing. Famously, Twitter had a lot of problems in the DevOps area. They were underpowered in the DevOps area when we saw a lot of fail whales. We don't see too many fail whales anymore, so they successfully transitioned to a very popular company. But it's the DevOps folks that take care of those kinds of things. I would say beware of the full stack label, but definitely don't completely understand what it means. It just means that there's so-called front-end hackers and back-end hackers. And the front-end hackers are more like the creative people, and the back-end hackers are more like the nerdy nerds. And there are some people that go through all of those worlds. And the thing is, the reason I say watch out for the label is that sometimes it gives off the wrong impression when you boast that you can, even if you've got some skills. It can be a warning sign to people who know and go, oh, really? Okay. Really what's happening is you would probably favor a certain stack of technology rather than know everything. No one knows everything about everything. Last person who did was probably Alan Turing. So if you're not afraid of looking at code, this is kind of the language suite that you want to get into, at least if you're going to become a website designer. On the left, it shows HTML code. It's just a container language. In the middle is a little column of CSS, and this is affecting the styles of what's in the document. And on the right is JavaScript, the actual programming that does actually execute on the internet, or I should say on the client of the internet. So it's a portable programming scripting language that ultimately can calculate operations. So that's where some of the magic of interaction happens. So if you look at a web page and something's just really blowing your mind what it's doing, it's probably a combination of these three and heavily leaning on JavaScript. Anyway, these three things put together would look something like this on a page. And if I were to, I'm just going to go back to the presentation and see where we are with time, because it looks like my time is running out. But I at least want to show you that you can put all those three languages in one page if you want. And to show that, I will flip from sharing the PDF to instead, if it works, sharing this. Let's see. That's actually where I created the PDF. Hang on a second. Here. So this shows all of those three languages in one document. Now, really want to just flip back and see if I've got any questions or anything like that. But if you do want to get into DevOps, I want to show you that these basic requirements are something you're going to want to pay attention to. These requirements are, are refined down to Unix-based computing, because I'm not going to talk about Windows so much, but you can emulate Linux on Windows if you install and run Bash with PowerShell. So you're effectively running an Ubuntu Linux distribution. If you're on Mac, you don't have to worry about such things because you're already running a Unix machine underneath the covers. You can have access to it if you go open your Finder application, look under Applications, Utilities, and find the Terminal app. Double-click that, and you'll get a command prompt. And if it freaks you out, you can close the window. If it freaks you out, you can also type exit in it, and it will close. And you could, and you don't have to worry about things if you already know about the terminal because you're running Linux or BSD. But anyway, what I'm going to do here is just leave this open and quickly run through commands. Whoops. That you would want to know at least, basically, which would be Control C, which is an awesome escape thing. So if you're in a terminal and you're running a process and it seems to be getting away from you, make sure you know about Control C. Sometimes if you just hit Q, it works before having to resort to Control C. And you're going to want to be able to list the contents of where you are so you can see stuff. And there's this thing called cat head tail. So cat is reading back the files of the content of a file to your terminal application. Head, which will read the first lines, and tail, which will read the end. And finally, you're going to want to most definitely learn to use a pipe, which allows you to take the output of one process you're doing and input it into a second process. So those are the basic things you're going to need if you're going to want to get into system administration. You're going to want to play around with those most basic things to sort of navigate your own computer. And again, you can pull this terminal up by going, if you're on a Mac, by going into, from Finder, going into Applications, Utilities, Terminal, and try running a couple of these things. You're not really going to blow up your computer. If you're if you're already running a Linux, I assume you probably already know this stuff because it's, pretty part and parcel to that platform. If you're on a Mac, Microsoft, again, install Bash. Microsoft released Bash just this summer. Install PowerShell with it, and you can start taking advantage of a lot of the stuff that Linux users are doing, Linux and Unix users are doing all this time. I've listed here a couple intermediate things and a couple advanced things. I'll probably stick it on GitHub, or happy to share it afterwards. But really, I want to be very sensitive to time, and I want to thank TransHack for inviting me to speak. And I hope you got something from the presentation. I hope it was interesting, and I expect your takeaway would be, anything that you gleaned from that.